Welcome to EngineerUp, helping students, professionals, and job seekers grow smarter every day. Like, subscribe, and if you find this useful, please like and subscribe to my channel for more content like the one below. This detailed breakdown of alloying elements and their engineering applications is essential in mechanical design, material selection, and manufacturing. Effects of alloying elements in engineering materials. First alloying element, carbon. Symbol, C. Typical base metal, iron, steel. Effects on material properties. Increases hardness. Increases tensile strength. Reduces ductility. Forms carbides. Essential for heat treatability. Second alloying element, chromium. Symbol, Cr. Typical base metal, iron, nickel. Effects on material properties. Increases corrosion resistance. Improves wear resistance. Adds hardness. Forms hard carbides. Key element in stainless steel. Third alloying element, nickel. Symbol, Ni. Typical base metal, iron, copper. Effects on material properties. Improves toughness. Enhances ductility. Increases impact strength. Improves corrosion resistance. Used in cryogenic steels. Fourth alloying element, manganese. Symbol, Mn. Typical base metal, iron. Effects on material properties. Enhances hardness and toughness. Acts as a deoxidizer during steel making. Improves hardenability. Fifth alloying element, molybdenum. Symbol, Mo. Typical base metal, iron. Effects on material properties. Increases strength at high temperatures. Improves creep resistance. Enhances toughness. Aids in hardenability. Sixth alloying element, vanadium. Symbol, V. Typical base metal, iron. Effects on material properties. Refines grain size. Increases strength and fatigue resistance. Enhances wear resistance. Forms vanadium carbides. Seventh alloying element, silicon. Symbol, Si. Typical base metal, iron, aluminum. Effects on material properties. Deoxidizer. Improves magnetic and corrosion resistance. Used in spring steels. Adds fluidity in castings. Eighth alloying element, tungsten. Symbol, W. Typical base metal, iron. Effects on material properties. Very high melting point. Improves hot hardness. Enhances wear resistance. Used in cutting tools. Ninth alloying element, cobalt. Symbol, Co. Typical base metal, iron, nickel. Effects on material properties. Enhances hot hardness. Improves magnetic properties. Resists oxidation at high temperatures. Used in tool steels and magnets. Tenth alloying element, aluminum. Symbol, Al. Typical base metal, iron, copper. Effects on material properties. Acts as a deoxidizer. Improves corrosion and oxidation resistance. Strengthens alloys via precipitation hardening. 11th alloying element, copper. Symbol, Cu. Typical base metal, iron, aluminum. Effects on material properties. Enhances corrosion resistance. Especially effective in atmospheric exposure. Used in weathering steels. 12th alloying element, boron. Symbol, B. Typical base metal, iron. Effects on material properties. Improves hardenability. Effective in very small amounts, ppm level. 13th alloying element, titanium. Symbol, Ti. Typical base metal, iron, aluminum. Effects on material properties. Refines grain structure. Forms stable carbides/nitrides. Improves strength. Key in aerospace applications. 14th alloying element, niobium, columbium. Symbol, Nb. Typical base metal, iron. Effects on material properties. Increases strength. Controls grain growth. Improves weldability. Enhances creep resistance. 15th alloying element, lead. Symbol, Pb. Typical base metal, iron, copper. Effects on material properties. Improves machinability. Acts as a lubricant during cutting. Used in free cutting steels. 16th alloying element, phosphorus. Symbol, P. Typical base metal, iron. Effects on material properties. Enhances machinability. Improves corrosion resistance. Reduces toughness, causes brittleness if excess. 17th alloying element, sulfur. Symbol, S. Typical base metal, iron. Effects on material properties. Improves machinability. Excess can cause hot shortness, cracking. Common in free machining steels. 18th alloying element, zinc. Symbol, Zn. Typical base metal, copper, aluminum. Effects on material properties. Forms brass, CuZn. Enhances strength and corrosion resistance. Lowers melting point. 19th alloying element, magnesium. Symbol, Mg. Typical base metal, aluminum, steel. Effects on material properties. In aluminum, improves strength and weldability. In steel, acts as a desulfurizer. 20th alloying element, tin. Symbol, Sn. Typical base metal, copper. Effects on material properties. Increases corrosion resistance. Key in bronze, CuSn, alloys. 21st alloying element, calcium. Symbol, Ca. Typical base metal, steel. Effects on material properties. Acts as a deoxidizer and desulfurizer. Improves surface quality and machinability. Typical engineering applications. First application, stainless steel. Key alloying elements, chromium, Cr, nickel, Ni, molybdenum, Mo. Purpose, corrosion resistance, high strength. Second application, tool steels. Key alloying elements, carbon, C, tungsten, W, vanadium, V, molybdenum, Mo, chromium, Cr. Purpose, high hardness, wear resistance. Third application, high-speed steels. Key alloying elements, tungsten, W, molybdenum, Mo, vanadium, V, cobalt, Co. Purpose, retain hardness at high temperatures. Fourth application, weathering steel, Corten. Key alloying elements, copper, Cu, phosphorus, P, chromium, Cr. Purpose, atmospheric corrosion resistance. Fifth application, aerospace alloys. Key alloying elements, titanium, Ti, vanadium, V, aluminum, Al, molybdenum, Mo. Purpose, lightweight and high strength. Sixth application, brass, CuZn. Key alloying element, zinc, Zn. Purpose, machinability and corrosion resistance. Seventh application, bronze, CuSn. Key alloying element, tin, Sn. Purpose, toughness and corrosion resistance. Eighth application, aluminum alloys. Key alloying elements, magnesium, Mg, silicon, Si, copper, Cu, zinc, Zn. Purpose, lightweight, corrosion resistance. If this helped you, tap the like button. Subscribe for more real-world engineering tips. Share with someone who needs this.